Let's take a look at these two review problems. First, let's state the definition of e to the z if z is permitted to be a complex number. The definition is that e to the z is defined to be summation n equals 0 to infinity of z to the n over n factorial. So e to the x is defined as the inverse of natural log x if x is real. And then later on we show the Taylor expansion for e to the x is pretty much what's on the screen now, and we extend that to complex numbers. This series converges by the ratio test, and so we don't have to worry about the radius of convergence. How about e to the ix? Well, let's see, e to the ix would be equal to summation n equals 0 to infinity of I times x to the nth power over n factorial. Okay, now let's just start plugging in numbers and seeing what happens. If we plug in 0, we get 1 over 0 factorial. If we plug in 1, we get I times x to the first power over 1 factorial. Then I times x to the second power over 2 factorial. Then let's take this out to about 7 terms, or to the 7th power, pardon me. I times x to the third over 3 factorial. I times x to the fourth over 4 factorial. I times x to the 5 over 5 factorial. I times x to the 6th over 6 factorial. I times x to the 7th over 7 factorial. And we proceed infinitely many terms, just like this. Okay, now let's break this up into the real terms and the imaginary terms. The terms that are going to be real are going to be, well, the first term, I over 0 factorial. The next real term will be the squared term. I squared is negative 1. Then I have x squared over 2 factorial. The next real term would be the fourth power. I to the fourth is plus 1, so we have x to the fourth over 4 factorial. Then the next even would be minus x to the sixth over 6 factorial, because I to the sixth power is equal to negative 1. And then we continue on like this, alternating between plus and minus. So that's the term with all real terms. Then let's take a look at the thing that has all imaginary terms. The first one, of course, will be the first odd term, I times x over 1 factorial. So we have x over 1 factorial. And I have pre-factored the I out. Next would be the next odd term. I to the third is negative I, so negative I times x to the third over 3 factorial. Next we have I to the fifth power. I to the fifth power is plus I, so plus I times x to the fifth over 5 factorial. Next we have I to the seventh. I to the seventh is negative I, so negative I. And we have x to the seventh over 7 factorial. And so on, alternating plus and minus. And you should recognize that the first set of brackets is the Taylor expansion for cosine of x. And the second Taylor expansion is, the second series is the Taylor expansion for sine of x. And so if x is a real number, then e to the ix is equal to cosine of x plus I sine of x, as justified by looking at the Taylor expansions that you see on the screen.